example, regression, it uses to estimate how much it is accurate or how much it is approaching towards the real value. That is, it is a continuous value. That continuous value uses for giving some predicted value, but it does not exact output. Exact output means that the output, it may not be definitely with the real value. It helps for giving some approached value. But if it is classification, it uses for grouping into subcategories that has been defined previously. And there are different types of regressionists. Like, for example, the first one is linear regressionists. Linear regression, it has only one input. Like, for example, if we have some x value is equals to, or some like y value is equals to wx plus b value, this b value. So this x, if this x has a single value, then we can say that it is a linear regression type. Linear regression type. Like this linear regression type it has only one input and the corresponding outputs. And there are also polynomial regressionists where we have a number of inputs from different sources. As I told you, from big data, we have a number of we may have a number of sources that will input or that will insert into our the algorithm. Like, for example, from social media, from agriculture, from governmental sector, from non-governmental sectors, they may be aggregated and then combined and processed through the Hadoop, as we have remembered previously. It is called big data. So in big data, okay. መልኬ ገብተሃል አይደለ? አሁን መልኬ ጽፈህልኝ ነበረ። መልካሙ ወይም መልኬ ጽፈህልኝ የነበረ ግሩፕ ላይ ጽፋ ነበረ። Do you join ours? Have you joined? Dr. Melke Alebe, please let me. Okay. So this polynomial regression, it uses for, bringing different sources together for combining various variables so that we can see that it is the polynomial regression. This polynomial regression, as you have remembered from different mathematical courses, there is a quadratic, for example. Here is the quadratic regression. This quadratic regression, it will move up, or it may be down, or it may be up and down like this. So there are a number of, it depends on the exponent, the largest exponential value of the given variable. This is it is a cubic, and here it is the second one it is a quadratic. And this polynomial regression usually it has a number of up and downs. And like, for example, sigmoid. Sigmoid, it has it is an activation function having different different ranges of variables, and it may have a number of variables, and that variable, it may have some up and down values. That is, it is an example of these polynomial models. But if it is linear, it is a straight line, and it is impractical whenever the data set is nonlinear, it is very difficult to classify data based on, using this straight line. Or whenever you have a data set having different natures or nonlinear nature, it is very difficult to regret or to predict using a linear value. So that's why this polynomial regression is mandatory. And the other one is about logistic regression. This is usually it uses for computing some probability values using some trigonometric functions like tonnage. That tonnage, like this tonnage, it varies between -1 and +1. This tonnage, and if it is sigmoid, it will be 0 and 1 value. This sigmoid value. So these two values are very essential values that uses for determining the given data to be, normalized in between the two distinct values. That is, it is logistic regressions. Logistic regression. Okay. I hope has the ተማሪ ገብቷል። ማክሲመም 29 ተማሪ መሰለኝ እስካሁን አቴንድ እያደረገ ያለኝ። So let us continue. Now this logistic regression, as you see, from used to estimate the probability that an event will occur as a function of other variables. That is, it is called logistic regressions. And the probabilities that a borrower will default as a function of the credit score and income and the size of the loan and his testing, exiting debits. Those are some variables that cannot be determined as a linear values. That usually they are probabilistic values. That probabilistic value, it is called logistic regressions. And the other one is about binary and multi-class classification. Usually, if it is binary, as a name, it is only 2 class. And if it is multi-class, it has 3 or more than 2 classes. So as the number of classes are increased, like if it has 10 class, it will be very difficult for estimate. But I'm not saying to you that you should not use that 10 or more than 10 class. I am not saying that. But as the number of classes is increased, the complexity is going to be increased. So that we have to have some optimization technique that hinder or that minimize the complexity of the operations or the error. And logistic regression is, it is this is the function how it maps from the source to the default or to the y value. So this f is a function that uses for mapping the given value into the target values like sigmoid value or some tonnage values. And the regression usually it is estimate towards the predict the exact value. So those pointers around the line, they are called it is predicted value. So usually this regression, it has been computed using like mean square error or mean square error or mean absolute error or any evaluation parametrics that use for regressions like mean square error, mean absolute, MAE. This, so whenever mean square error is large, then it will be difficult to estimate. So the main objective of our work in regression is minimizing mean square error, minimizing mean absolute error, maximizing the accuracy, and maximizing the maximum error, minimizing the maximum error, minimizing the average error, minimizing the minimum error. That is the main objective of regression. And the second point is about classification, and this classification it uses for classifying into groups, and it is the easiest approach. Why? Because the target values are true. I mean, they are already known, so that it is easy for classifying as class 1, class 2, or class 3, or class 4, and so on. So classification, it is one of the approach, but it does not mean that you have to, I mean, your work may not be focused on this classification. While it is easy, the data nature matters to use this classification. And not only the data nature, the data, the whole property, it matters, or it affects the algorithm types that we used. So, but you can combine this classification with regression. Classification, one thing that uses for grouping, and regression for predicting. So how we can combine this classification and regression? That is the main thing that you should know. The classification and regression should combine together. Why we combine them? Because sometimes classification may not be important for our work, or regression may not be important for our work, or the output of classification may support for regression, or the output of regression may use for in the classification operation. So usually it may be have classification then regression, or you may have some regression then to classification, or simultaneously regression plus classification is equals to some operation output. It is called hybrid operation. Regression plus classification can be combined together to give some output, and this combination they may compute in an end-to-end format. End-to-end mean that it is not hierarchical. So classification and regression can combine together in the hierarchical form, or they can combine together in an end-to-end form. End-to-end, what does that mean? Both the classification, the regression are computed simultaneously, without just the one weighting the others, the one weighting the others. That it is called classification. I mean, hybrid operations or end-to-end operation. So end-to-end, you can use some data analysis techniques, like, for example, estimating like, for example, the investor, in estimating investor business like transactions using end-to-end machine learning. That is one of the approach. That end-to-end is the new technology in machine learning. End-to-end parallel learning, end-to-end learning, hierarchical learning የሚባሉ የለርኒንግ ሜካኒዝሞች አሉ ማሽን ለርኒንግ ላይ ምናልባት ከተማራችኋቸው። So that end-to-end learning, it uses to learn without any hierarchy. So from the classification, we have to see that the Bayesian belief network, or Bayesian classification, this Bayesian classifier, it uses some probability technique for estimating some values. It is called Bayesian classifiers. And this classification, it uses usually it is conditional probability. Like, for example, this is the formula: probability of some variable big X is equals to the summation of, like, or some products of the probability of a sequence of numbers. That is this conditional probability. ኤክስቴንሽኖች ስንት ናችሁ? ኤክስቴንሽን ተማሪዎች how many?
16.
16?
Yes.
Okay, 16. ኢኳል ነው ትሉኛላችሁ መሰለኝ። ሶሪ ሜሴጃችሁን አላየሁትም። ከኔ በኩል ምንም የተከፈተ ነገር የለም ሌላ ነገር። ከእናንተ በኩል ሁለት ነገር ከከፈታችሁ ኢኮል ሊኖረው ይችላል። ከጎናችሁ ያለው ወይ ሚዩት አድርጉት። ሁላችሁም ሚዩት ካደረጋችሁት ድምፅ ይጠፋል። ከነ ከሪጉላር በኩል ስንት ተማሪ ነው ያለው? ሙሌ
10
16 26 ኦንላይን ማየው 30 አካባቢ ተማሪ ስለሆነ ነው። ኤኒዌይ ችግር የለውም። 30 አቴንድ የሚያደርግ ሰው አለ ብዬ አይቼ ነው። ግን አንድ ሰው በሁለት ምናምን ገብቷል። ለምሳሌ ናቃቸው በሁለት ነው የገባው። አንደኛው ማድረግ ትችላለህ። ሞባይልም በእንትንም ስለገባህ ሊሆን ይችላል። መልካሙ አበዋ በ3 ነው የገባው። የሀብቱ ሪሙቭ ዋን ኦፍ ዘም ምናልባት ጓደኞቻችሁ በእናንተ ካልገቡ በስተቀር እንደዛ ማድረግ ትችላለህ። ኤኒዌይ ኖ ፕሮብለም። So we can have the Bayesian belief networks. This Bayesian belief network based on different scenarios. Like for example, if you have some if you have a family history, for example, FH, with having the smoking character or behaviors, and family behavior, family history having a lung cancer, family history with employment, have family history with positive X-ray, family history with dysphagia. So those are some of the characteristics that used for classifying the family history. Like for example, family history with some smoking, which have lung cancer, the probability is 0.8, which is 80% of the probability is the smoker will have some cancer, and 20% they don't have lung cancer, and or some smoker or family history having the lung cancer is 0.8 the probability, but this is the person having no cancer, which is 20%, and family history with no cancer, this no cancer, but having the lung cancer. The family history who have not smoking history, but they have lung cancer, like 50%, having lung cancer, which is 50%, have not lung cancer, which is 50%, and the family history, the negation of family history, which is the one who has not family history but has a smoking behavior, which is 70%, and 30% will be with no cancer, no lung cancer, and so on. This is some probability. So this is a conditional probability. That is, it is called Bayesian probability. So this Bayesian probability, it may have some scenarios, like 4 scenarios. One variable, one behavior, they may have different scenarios. So here, what I need, whenever you test your work, you may have a number of scenarios. ለምሳሌ ቢግ ዳታ ላይ እኛ አንድ ፔፐር ላይ የሰራሁት የዳታ ኮምፕሬሽን ወይም ዳይሜንሽናል ሪዳክሽንን አፕላይ ከማድረግ በፊት አንድ ሴናሪዮ ዋን አልኩት። ዳታ ኮምፕሬሽንን አፕላይ ካደረግኩ በኋላ ሴናሪዮ ቱ አልኩት። ስለዚህ ሁለት ሴናሪዮ ነበረኝ እኔ ለመስራት የትራኪንግ ሲስተም ላይ ስሰራ አንድ ሴናሪዮ ዊዛውት አፕላይንግ dimensional reduction, and scenario 2 after applying dimensional reduction, the second scenario. So you may have a number of scenarios, like for example here it is the table, it has about four scenarios. So you may have a lot of scenarios. Here it is the example, like for if you need to apply like a mortality rate of children in Ethiopia, you may have a lot of scenarios. Like for example, the first scenario may be people from the rural area. The second scenario, it may have people from the city, but they don't have sufficient income. People who have like for example health insurance, people who have not health insurance, different scenario. You can bring different scenario. People who born before 20 years, ከ20 ዓመት በታች ያሉ ሰዎች እናቶች የወለዷቸውን አንዳንድ ሴናሪዮ እንወስደው እንችላለን። You may have a lot of scenario whenever you discuss just ከ20 ዓመት በታች የሆነው የሞርታሊቲ ሬት አማራ ክልል ይሄን ያለው ብቻ ብለን አይደለም ማለት ያለብን። ይሰማል አይደል? ሁላችሁም ቴክስታችሁን ስለማላይ ይሰማል። ካልተሰማ ድምጻችሁን እንትን በሉኝ፣ ምናልባት የመቆራረጥ ነገሮች ካሉ። So you may have a number of scenarios. የውሃ ልማት አካባቢ ስንሄድ የጎንደር ህዝብ የውሃ amount of water consumption ካልኩሌት አድርገን ህዝቡ ይሄን ያህል ኮንሳምፕሽን አለው ብቻ ማለት አንችልም። because the people who has individual life are absolutely different from the merchants or from the hotel owners. የሆቴል ኦነሮች የሚጠቀሙትና የኢንዲቪጁዋል ግለሰቡ የሚጠቀምበት ያጠቃቀም ሁኔታ ይለያያል። So we have to have some scenarios to classify as different components like entities or some attributes or some structures or some data groups based on different algorithms. You may have a number of algorithms for classification, for example. As you see, Bayesian classifier, one of the scenario, and SVM is another scenario, MLP another scenario. These all are algorithms. So you have to have some scenarios to convince your audiences. The formulation is the same. Here it is the same. The Bayesian law, using the Bayesian law, you can use some classification algorithm. Some classifications. Like for example, probability of B given A is equals to probability of A intersection B over probability of A. Here it is the formula. When we use this, whenever the variables are independent, when one not affect the others. So do you think that your variable is independent variable or dependent variable? If you need to do such a type of work, you have to select only independent variables. It is called Bayesian classifier. Here the formulation and the explanation. Another very important thing is for classification, it is feed forward algorithm ይባላል። feed forward algorithm. This feed forward algorithm, it is the multi-layer, the first deep learning algorithm that uses for classifying the given data into different classes. So like for example or predicting a number of input you may have. By the way ፊውቸር የሚባል እንዲህ አይነት ኤክሴል አለ አይደል? አሳይመንት የሰጧችሁን አይታችኋል አይደል? ዩ ጋይስ አግኝታችኋል አሳይመንታችሁን? አላገኛችሁም? ኦኬ ፋሲል እና ፋሲል አግኝተውታል። ኦኬ ምን ይላል? ፐብሊክ ዳታ ተጠቀሙ ነው አይደል ያልኳችሁ? ፐብሊክ ዳታ ማለት እንደው እንደ ተጨማሪ ይሄን ቻፕተር ስለሚመለከተው ነው። ፐብሊክ ዳታ ማለት ኦፕንሊ ዩ ካን አክሰስ ፍሮም ኢንተርኔት ማለት ነው። ከኢንተርኔት አክሰስ የምታደርጓቸው ዳታዎች ነገ ግን የእናንተን ስራ ልትሰሩበት የምትችሉት ባይ ዘ ዌይ you have to select the data set that will be related with your ሪሰርች ነገ ፕሮፖዛል ጻፉ ትባላላችሁ እና ከዛ ጋር ግንኙነት ያላቸው ነገ እናንተ ሲሰሩ ኤክስፐሪመንታል ዳታ ልትጠቀሙ ትችላላችሁ። ግን ከዛ ጋር የተገናኘ ነገር ቢሆን ሊትሬቸር ስታነቡ፣ ኢምፕሊሜንቴሽን ስታዩ፣ ሶፍትዌሩን ኢንስቶል ስታደርጉ፣ ራን ስታደርጉ እነኚህ ሁሉ ለኋላ ስለሚጠቅሟችሁ you have to use data set from the ኦኬ አሁንም አለ ኢኮ አለ ይለኛል።
በእኛ በኩል አይሰማም፣ ፒውር ነው። በእኛ በኩል ምንም ኢኮ የለውም፣ ጥሩ ነው ድምፁ።
በቃ ስለዚህ በእነሱ በኩል ያለ ችግር ነው ብዬ አስባለሁ። ኦኬ ድምፄ መጨመር ካለብኝ ስፒከሩን መጨመር እችላለሁ። ኦኬ ሶ ዳታ ሴታችሁ ሁልጊዜ ኮሌክት ስታደርጉ ከእናንተ ሪሰርች ጋር ግንኙነት ያላቸው ቢሆኑ ኢሜጅ ላይ መስራት ከፈለጋችሁ ባይ ዘ ዌይ ኤኒባዲ ካን ኮል ሚ። ኮንፊውዥን ካለ ምን አይነት ዳታ ነው የምንጠቀመው፣ እንዴት እናድርገው፣ እንዴት አይነት ኢንስቶል እናድርገው፣ ኤቭሪቲንግ ዊ ካን ዲስካስ ኤኒ ታይም። ፍሪ እስከሆንኩ ድረስ ስልካችሁን አንስቼ ማውራት እችላለሁ። ኤኒ ኮንፊውዥን ሲፈጠር ዩ ካን ኮንታክት ሚ። ሶ ከተለያየ ዳታ ሴት ኮሌክት ካደረጋችሁ ኦንላይን ካወረዳችሁ በኋላ ለዛ ደግሞ አፕሮፕሪየት አልጎሪዝም ትጠቀማላችሁ። ያን አልጎሪዝም ከእናንተ ስራ ጋር ነገ እንሰራዋለን ከምትሉት ኤግዛክትሊ ተመሳሳይ አይደለም የሚሆነው፣ ግን እናንተ ከምትሰሩት ጋር ነገ ፕሮፖዛል ጻፉ ትባላላችሁ። ፕሮፖዛል ዲፌንድ ታደርጋላችሁ። ፕሮፖዛላችሁን ዲፌንድ ካደረጋችሁ በኋላ ሌላ እንትን ትላላችሁ። ከሃዱፕ ውጭ መጠቀም እንችላለን ነው ያለኝ። ከሃዱፕ ውጭ ትችላለህ፣ ስፓርክን መጠቀም ትችላለህ። እናየዋለን የቻፕተር 6 ላይ የምናያቸው እንትኖች አባውት ሃዱፕ እና ስፓርክ እናያለን። ሃዱፕን እንዴት እንደምንጠቀመው ስፓርክን እንዴት እንደምንጠቀመው በተወሰነ ኦቨርቪው ሰጣችኋል። so that you can use spark or hadoop whatever it is የእናንተ ፍላጎት ነው። ነገ ዳታ ሳይንቲስት እንሆናለን ብለን ለምናስብ ሰዎች፣ ዳታ ሳይንስ ውስጥ ኦንላይን ስራ እንሰራለን ብለን ለምናስብ ሰዎች፣ ወንድሞቻችን ዘመዶቻችን ወይም ደግሞ በአካዳሚክስ ግንኙነት የነበረን ሰዎች ነገ ስራ ይፈልጉልናል ብለን ለምናስብ ሰዎች ጥሩ ነገር ሰርተን ማሳየት ያለብን ይመስለኛል እና ከዛ አንፃር እንድታዩት ነው። ሶ ዳታችሁን አክሰስ ካደረጋችሁ በኋላ ለዛ ዳታ አፕሮፕሪየት የሆነ አልጎሪዝም ማድረግ መቻል አለባችሁ እና ይሄ መልቲሌየር ፐርሴፕትሮን ለምሳሌ you see this multilayer perceptron it is one of the algorithm that uses for estimating the classification. It is usually fully connected ማለት ለምሳሌ ፊውቸራችሁ 10 ቢሆን ይሄ አንድ ፊውቸር 1 ማለት ናት። እቺ ፊውቸር 1 ወይም አትሪቢዩት ነው። ፊውቸር 2 ፊውቸር 3 ፊውቸር 4 ፊውቸር 5 6 7 8 9 10 እያለ እስከ ፊውቸር 10 ድረስ ኖራችሁ ማለት ነው። ዴን የመጨረሻው አውትፑት ይሆናል፣ ክላሱን ሊይዝላችሁ ይችላል። ሶ እነኛ 10 ፊውቸር ካላችሁ ስንት ኒውሮን ያስፈልጋል? ኢንፑት ሌየር ላይ ዚስ ኢንፑት ሌየር ላይ 10 ያስፈልገናል። አንድ ይቺ 2 and this is the one 3 the 4th 5th and 6th 7th 8th 9th and the 10th one. This is, and if you have one class ማለት ታርጌታችሁ አንድ ከሆነ ይችኛዋ እነዚህ ሁሉ ተሰብስበው ወዴት ይሄዳሉ? ወደ አንድ ክላስ ይሄዳሉ። በፉሊ ኮኔክትድ ማለት ይቺ አውትፑት ናት ወይም ክላሷ ናት። ክላስ የምንላት ሶ እነኚህ አስሮች ሁሉ እነኚህ ኒውሮን ናቸው። የመጀመሪያው ወደዚህ ይገባል፣ ሁለተኛው 3 4 እያለ ሁሉም እነኚህ ኒውሮኖች ይቀበላሉ። ማሽን ለርኒንግ ላይ ከተማራችሁ እነኚህ የፉሊ ኮኔክትድ ፕሮብለሞች አንዳንዴ ኦቨርፊቲንግ ፕሮብለም ሃፕን ስለሚያደርግ ይህም ፕሮብለም ኦቨርካም የምናደርግባቸው 3-4 ቴክኒኮች አሉ። ለምሳሌ ኤርሊ ስቶፒንግ፣ ድሮፕ አውት አይደለ? ኤርሊ ስቶፒንግ የሚባል ተምራችኋል። ኤርሊ ስቶፕ ማለት ይሄ ማሽን ለርን ሲያደርግ ኦፕቲመም ቫሊዩን ካገኘ በኋላ ከዛ በኋላ ለርን እንዳያደርግ ማድረግ ማለት ነው። ክላሲፊኬሽን እና ሪግሬሽንን ዳታውን ትሬኒንግ እና ቴስቲንግ ዳታ ሴትስ ክላሲፋይ ስናደርግም ችግር ሊኖር ስለሚችል ኬፎልድ የሚባልም እንጠቀማለን። ሶ ዜር አር ነምበር ኦፍ አይ ካን ሼር ምናልባት ክላስ ሪፕሬዘንታቲቮች ጥያቄውን ከጠየቀ እንትን ካሉኝ በተለይ አንዳንድ ቻፕተሮችን ሸር ላደርጋችሁ እችላለሁ። እንዲህ አይነት በምን ወይ ነው ኦፕቲማይዝድ የምናደርገው ማሽን ለርኒንግ ላይ ወይም ደግሞ እዚህ ቢግ ዳታ አናሊሲስ ላይ ዳታን ካገኘ በኋላ ፐርፎርማንሱን እንዴት ኦፕቲማይዝ እናድርግ የሚባል ከሆነ አይ ካን ሼር ዩ one of the chapter from my lecture class to other students. So እንዲህ አይነት ቴክኒኮችን ስንጠቀም እነኚህ ናምበር ኦፍ ኒውሮን እና የኢንፑት ሳይዙ ተመሳሳይ ነው። ዴን ለርን እያደረገ ሄድና በሂድን ሌየር ላይ ዴን አውትፑት ሌየር ላይ ይደርስና ፋይናሊ we can evaluate ማለት ነው። አሁን እዚህ ጋር ኤቫሉዌሽን እንደርሳለን ማለት ነው። this is multi-layer perceptron እንለዋለን ፉሊ ኮኔክትድ ከሆነ ማለት ነው። እንዴት ለርን ያደርጋል? ሙሉ ኒውሮኖች ከኢንፑቱ ይቀበልና ዴን ይሄ ሁሉም ለሚቀጥለው ኒውሮን ይሰጣል። ይችኛዋም ለዚህ ትሰጣለች፣ ይችም ትሰጣለች። እያንዳንዳቸው ኒውሮኖች ለቀጣዩ ኒውሮን ይሰጣሉ። ለሁሉም ፉሊ ኮኔክትድ ማድረግ ማለት ያ ነው። ይሄ ፉሊ ኮኔክትድ ወይም ፎርዋርድ ብቻ ነው ለርን የሚያደርግ ባክ አያደርግም ማለት ከፊድባክ አይማርም ማለት ነው። ማሽን እንዲህ አይነት የማሽን ለርኒንግ አይነት ከመጀመሪያው ከፕሪቪየስ ኢንፑት ከፕሪቪየስ አውትፑት ለቀጣዩ ኢንፑት ይሆናል። እያንዳንዱ እስከሚያልቅ ድረስ ለምሳሌ አውትፑት ሌየሩ ይቺ አውትፑት ሌየሯ ከፕሪቪየስ ሌየሮች ሙሉ በሙሉ ኮኔክትድ ታደርጋለች እንደዚህ። ይሄ ማለት ከፕሪቪየስ ኢንፑት ለቀጣዩ አውትፑት ይሰጠናል ማለት ነው። ሶ ይሄን ተጠቅመን ነው እንግዲህ የአንዳንዴ መልቲሌየር ፐርሴፕትሮን የምንለው። ምናልባት ባለፈው ኪኖት ስፒከር ወይ የመጥቼ ካያችሁ መልቲሌየር ፐርሴፕትሮን ከሌሎቹ ከአርኤንኤን ታይፖች እንዴት እንደሚለይ ሃይላይት የተወሰነች ሃይላይት ሰጥቻችሁ ነበረ ዛ ፕሬዘንቴሽን ላይ። there are a number of learning mechanisms. This multi-layer perceptron is fully connected, that on which the previous layer is directly and fully connected with the next all of the neurons, and then it will continue until it reaches to the output layer. And yeah, here it is about the number of hidden layer, about the learning rate, and about the normalization. ዳታ ኖርማላይዜሽን ምን ማለት እንደሆነ ኖርማላይዜሽን አሁንም የኦቨርፊቲንግ ፕሮብለምን ፕሮቴክት የምናደርግበት ነው። የመጨረሻዋን ቻፕተር እንደውም የዚህ የቻፕተር 8 የመጨረሻዋን ቻፕተር እናካትተዋለን። የኦቨርፊቲንግ ፕሮብለምን እንዴት አንድን እንደምናደርግ እዛ ጋር እናያለን። the other one is about back propagation classifier ነው። here it is about classification we are just dealing about. Here the classification is both forwarding and backwarding. Both forwarding and backwarding. That is called fully connected. I mean the back propagation algorithm የምንለው ማለት ነው። It learns both forward and backward. Then from the feedback it updates the weight update ያደርግና እንደገና ይመለሳል ወደ ኢንፑት I mean ወደ አውትፑት, and then it going to back and then going forward and then back and then forward እያለ መጨረሻ ላይ አውትፑቱን የዋይ ቫሊዩ እናገኛለን ማለት ነው። ዛት ኢዝ ኢት ኢዝ ኮልድ ባክ ፕሮፓጌሽን የምንለው ማለት ነው። ሌላኛው የክላሲፊኬሽን አልጎሪዝም የክላሲፋየር ቢግ ዳታ አናላይዝ ለመስራት የምንጠቀማቸው አልጎሪዝም ልብ በሉ። ኤስቪኤም ማለት ቢግ ዳታ አናሊዝ ማለት አይደለም። SVM is an algorithm that used for analyzing big data. So big data analysis, whenever we say the big data analysis, there are algorithms, there are data sets, there are measurement mechanisms, there are evaluation techniques, there are softwares that use for storing big data. There are applications or frameworks that use for implementing these algorithms and data sets or aggregating the data sets, the storage like Hadoop and the application like algorithms SVM algorithm. You see, big data analysis ስናወራ እነኚህም ሁሉ በአንድ ላይ ኢንኮርፖሬት አድርጎ የያዘ ነው ማለት ነው። So there is a support vector machine. This support vector machine usually it uses for mapping the data from the source to the destination using some kernel. So there may be data sets here, the data set. So in this data set, there is a function f that carry and then move to the another form, another output, another kernel, another matrix. This using the kernel, the function. Then we can apply for output. That is overall the support vector machine way of classifying. ጠፍቷል ግን ዋይፋይ ስላለኝ is there any disconnection problem አለ አይደለ?
ጠፍተ ነበር፣ አሁን መጥቷል።
ግን ዋይፋይ ስላለኝ ምናልባት ኳሊቲው it may not be exactly quite good for as the previous, but we'll continue. ትንሽ ጠብቁኝ።